Hello, today we are going to solve this lab about the configuration of DTP protocols, and the objectives of this lab is to configure static trunking and to configure and verify the DTP. First of all, we have this this topology. We have S1 here, okay? It's connected to S2 via G01 here, and this switch S1 is also connected to another switch S3 via the interface G02, and this is also G02. However, on at S2, the switch S2 is connected to three PCs, PC1, PC2, PC3, and S3 is also connected to three PCs, PC4, 5, and 6. And as you will see throughout this lab, we'll try to configure VLANs on these branches of each switch. Okay, then as you see here, the PC is already configured with the IP addresses and subnet masks. And also all of them are already configured, and also we want to define three VLANs management VLANs at S1 and S2 and S3, and the name of the VLAN is VLAN 99. It's a standard with standard name with these three IP addresses 99.1, 92, 99.2, 99.3. Okay, okay. Now I want to close this because I already did the lab. I want to reopen it from scratch. So, background. As the number of switches in a network increase, the administration necessary to manage the VLAN and the trunks can be challenging. To ease some of the VLAN and trunking configurations, to make it easy, trunk negotiation between network devices is managed by the dynamic trunking protocol DTP. So if we have large number of switches within the network, we make the management of trunking as automatic, and to do so we use this protocol, the dynamic trunking protocol, to make the trunking between the switches automatic, as routing, for example, is done by several automatic routing protocols. They do updates, they communicate, they negotiate, they advertise their routing information to create and to make a stable topology. Then here it's very similar, so we depend on the DTP or dynamic trunking protocol in order to do negotiation between the switches, and then is automatically enabled. These negotiation capabilities are enabled on Catalyst, Switch Catalyst 2960 and Switch Catalyst 3650. Okay, so in this activity you will configure trunk links between the switches. For example, if we go here, as you see here will be VLAN 1, for example, VLAN 2, VLAN 3, or 10, 20, 30, and here the same 10, 20, 30. And as you see, if these LANs here will communicate with these LANs, so here we have to have a trunk. It means that this link should pass traffic for different VLANs that are already configured throughout in this place. And here also this should be a trunk. it means that it should pass different traffic from here to there or from here to there. So trunk should this link should be trunk to pass different types of traffic for different labs or switches, VLANs. So you will assign ports to VLANs and verify end-to-end connectivity between hosts in the same VLAN. Then you will configure also trunk links between the switches, and you will configure VLAN 999 as the native VLAN. Remember, natively VLAN, it's the LAN that it's for legacy use. It means that sometimes the traffic can't be tagged. So to do so, we create this LAN to VLAN 999 as native. It means that any traffic without a tag on the trunk will be passed or will be transmitted to the native VLAN. Okay, VLAN. Okay. So any traffic untagged, not tagged on this trunk, the switches will forward this traffic without tags to native VLAN. So it's like default VLAN, okay? When the tagging is not possible. Okay, part one, verify VLAN configurations. Verify the configured VLAN on the switches, on the three switches. Let's go and check. Okay, so we take this command, we go to the uh, to the we go to switch 1 or switch 2. We start from here. Okay, we enable mode, then we check the show VLAN brief. As you see here, we have the VLAN 1 is default, all ports are assigned. We have two management. I already created this. Okay, I suppose that these are not created. Okay, then we will check also in S1 enable, and we check also here the same. It's the same, so management 99, native 999. Assume that these two here are not there. And for S3 also we should do the same, and also the same thing is there. So as you see, all ports are assigned to the VLAN, default VLAN. We have two management LAN, management 99 and 999 native VLAN. So we created another native VLAN than the VLAN one. So we are done for three. Oh, or it's already configured by the author of this lab. So this is not error from my side. So it's there. So we have the same interface here. We have it checked for this part. Then repeat step A on S2 and S3. We did it already. They are all the same. They have all of them this VLAN 1 and have also VLAN 99 and VLAN native VLAN 999. Okay, and all ports are assigned to VLAN 1, which is the default. Part B, repeat step 1A on, which done. We have the results. What LANs are configured on the switches? So what are LANs configured on the switches. So, okay, okay. So the following LANs are configured as I told you here, from here to LANs and VLAN 1. So VLAN 1 it's default. VLAN 99 is for management and VLAN 999 is native. On the three switches the same, okay? So this is S3, S1 and S2. Then part 2. Part 2. Create additional VLANs on S2 and S3. We want to create new LANs on S2 and S3 because they are connected to PCs. So because they are connected to the end devices, they should have access mode, switch port access mode, okay? Here, because they are end devices. So we want to create these VLANs here. For example, on S2, create VLAN 10 and name it red. On S2, we create, okay, so we create here. We will configure on S2 these three LANs. Let's continue the exercise. Then create VLAN 20 and 30 according to the table. 10 red, 20 blue, 30 yellow. All of them are on S2. So we will write this script. Enable configure terminal VLAN 10 name red, then VLAN 2 name blue, then VLAN 30 name yellow. Okay. We can't. Okay. Red, blue, yellow. Let's continue. So in S2, this is S2. So config T. We are in the configuration, global configuration mode. Then VLAN 10. We create VLAN 10.